The methodology I'm going to use is really called the AI ladder. It's been inspired by Rob Thomas, and it's really this 4-step process where we are first collecting the data, then we are organizing it, analyzing, and infusing it. Okay, so we're not going to go to the infuse part today, but we're going to collect, organize, and analyze it. And there's always something with ladders. Okay, when you think about ladders, I cannot think about Donkey Kong and just going things and avoid that. And really, it's I think that the climbing the ladder is a bit like that as well, where you've got ambushes and things like that. So it's really about being careful and climbing this ladder, avoiding the pitfalls. Okay. Another way to look at that part is being really careful about our journey with the data itself. Okay. So the first part is we're going to take the data as we find it on the internet. We are going to ingest this data in Apache Spark, and that's going to be our raw data. Okay, that's the data as it's ingested, as it's there. Okay. Synonyms for raw data could be staging zone, landing zone, bronze zone, or even the swamp zone in the case of a data lake. And then after that, we are going to apply some data quality rules so that this data can be used in a more efficient way. And to do that, and the pure zone has also some I've got cheat notes, of course, about that. You can call it the refinery, the silver zone, the pond, the sandbox, or the exploration zone. Okay, I like pure. And finally, this pure data we can apply transformation on this pure data, and you get the rich data from that. Okay, and the rich data, you will also find names like production data, gold, refined, the lagoon, or the operationalization zone. Okay, so that's a crazy one. And finally, you're going to publish this data, and you're going to have actionable data. Okay, that's a mouthful. Let's drill a little bit more. And to do these examples, we are going to use Java because, as you can see clearly here, it's a much safer choice, right? I am going to simply get the data from GitHub through an automated process and from the Johns Hopkins Wheeling Schools of Engineering. They put all the data that the Johns Hopkins University has collected worldwide, and they put that in GitHub. That's where it starts to be a little bit interesting in terms of data flow. The data is pretty ugly when we get it. Okay, so and we're going to look at it a little bit more detail, but that's really how the data is. So the first extract here is what I want. Okay, you see in this extract that I want clearly a state, okay, a column state with a country, with the last update as an ISO date, the number of confirmed cases, the number of deaths, unfortunately recovered, active, and a key that I can use after to build aggregation on, right? And you can see that if I look at what I get for January or what I get for April, this is totally not what I want, okay? And let's look a little bit more at the data itself, as in this, as I think it's a little bit of live is not completely uninteresting in our situation. Okay, so here is the website for the Johns Hopkins, and you see that everything is kind of up to date. And I know it's a little bit small, but this is, for example, the data I was getting for April. So you see that there's a column called FIPS, a column called admin2. Why admin2? That's a mystery. Province _ state, country _ region, last update, lat, long _ confirmed, etc., and my combined key. Okay, so that's what I got in April. If I look at what I'm looking in February, you see that it's completely different. Okay, look at that. I've got province/date. I've got country/region. Last update. So the column names are completely different, and you see things like mainland China here. Okay, so I will see more in details. When you look at the dates, at the date time here, oh, that's kind of good. The date time is kind of good. It looks like it's really ISO with year, months, day, and the date. But if I look at the very first ones, what is that date format? Okay, it's a mix of dates in an American format and our timestamps in European format. So there's all these things where, as you can see, my data is definitely not as clean as I'd like. Okay, if I look back at my conclusions of analyzing this, I can actually show you what the organization step of the data actually helped me doing. Okay, so first I had to structure and normalize the data. Okay, as I said, dates are sometimes in ISO, sometimes in US, sometimes, as I just showed, combination of both. China is written ISO China or mainland China. Sorry, that's a typo here. And South Korea has 3 different variants. There's no unique ID for location in the early version of the format. Okay, so if you want to do aggregation per location, no way you can actually do that in a reliable way. And files are, of course, I didn't show you that, but files are, of course, in different encodings, which, as you can imagine, simplifies drastically what we can do with the data. Okay, so the idea is to create our pure data as part of this organization process and doing that. Okay, so let's have a look at code. So the first basic ingestion you could do in Spark is a star, and this is not really working because it's trying to combine everything together. Okay, so let's look at the reflex you would have as without even looking at the data. So as you can see, in my class here, I've got my start method. That's where everything starts. I'm going, you see, to synchronize, just synchronize my repository from GitHub to my working directory for my data. And then I am going to build a session, a Spark session. And after that, I am going to just, wrong example. Sorry. So that's the beauty of life. Okay, so it's a simple data ingestion here. I was at a session, you see, that's the same thing. And then I am going to ingest, you see here, file names, and I'm going to ingest everything. That would be a very efficient way to ingest all the data in Spark if the data was exactly matching the same format all along, okay? So that would be the first reflex you can have, and you look at the data and then you find that it's not exactly how I'd like that to be, right? I had to do a little bit different things and to look at that, okay? So let's drill a little bit into this. This is not really easy Spark. It's kind of, I would say, advanced Spark. And this is the example where I am going to build my pure data. If I look at my application here, okay, so very similar. I like to show the imports I'm using. So basically, the data set, the row, and combined, they do the data frame. And then we're going to have a Spark session and a bit of logging and a few utilities I have, okay? So in my main, the only thing I do is I instantiate an instance of my class and do a call start. And start, what does start do? As before, it exactly does the same thing. Create a Spark session. Okay, you can see here the Spark session. After that, you can see I've got a special configuration part, the configuration property here for Spark 3, and creating the session. Okay. After that, I'm just asking Spark to ingest all that. That's it. That's one method to ingest that. Okay, and we're going to drill a little bit into that. if I look at that, at this method here, ingest, so the first thing I'm going to do is sync the repository. And this is really about cloning the repository from GitHub to my local directory. Then I will go through each file, okay, creating creating a list of files that is ending with CSVs. That's my next step. And then from that, I'm going to go through each file and look at it. So what am I going to do? Here, the first thing is I'm creating this instance of a dataset of row. And this instance of dataset of row is a data frame. Okay, so it's still pointing to null for now, but I will need it after. So here I'm going, the first thing I'm doing is I'm extracting the header from the file. One way I noticed is that to determine for me which way to ingest the data was actually to look at the header. Okay, it is different, and so I will ingest each file through the different header. And when I'm doing that, I'm actually looking. I'm looking at I'm reading the header. If the header, there's a small caveat as well. You know, there's this first character of the file, which can sometimes be tricky for you and tell you the encoding. Well, then actually, if this is there, I'm actually just going to remove this Unicode character that is actually painful. Okay, so that's what I'm doing here. And then after that, I am going to ask my main ingester to ingest my file based on the header I just detected, and store that into an intermediate data frame. So, and that's what I'm doing. Then I'm calling main ingest, and what is done main ingest is simply going through each header, having a case. So for early January, February, March, and April and later. After April, they decided not to change the format anymore. But this is really, you've got your case here, okay, which based on the header. You've got the case for February and after, and that's what I'm doing, okay? So if we look in details at the first pass, which is the ingester one, okay? So ingester one, what it's doing is it's actually looking at the schema, okay, and it creates, it's not looking at the schema, it's building a custom schema for each file, and for this specific format of file. So I can specify my column name, and I can also specify the type and whether it's required or not. And I'm doing that for state, country, last update, confirmed, death, recovered, active, combined key, incidence rate, and case fatality ratio. Okay, so that's my schema. Then I'm ingesting it. And the order of things is important there. And then you see it. So I'm asking my session, read. The format is a CSV. I'm specifying my schema. Okay, I'm specifying that I have a header. I'm specifying the timestamp format I'm reading in this file. Remember, every file may have a different timestamp format, and then I'm loading that. Okay, and for the missing columns, then I'm actually adding a null value to the column called FIPS and mean latitude and longitude when it does not exist. Okay, and I'm doing that for every format. So you see here that was my format 1. Okay, and sorry, I'm going back to main ingest. Main ingest is there. That was for early January. If I look at what I got in February, for example, we're not going through all of them. You can do that by yourself. I'm looking at this ingester. So it's the same strategy here. Building a schema. And this schema, I've got actually state, country, etc. So you find the same fields, same, of course, same data types, and you are going to I'm going to do the same thing here. Here, notice that in this case, I have all the columns already and all the values, so I don't need to add them null values to those. Okay, so I have the same strategy for reading it. See, creating my data frame, asking the Spark session to read a file in format called CSV, specifying a schema, having settings that I have a header. See, I don't have a timestamp here. Spark is smart enough to detect for this the right time format, the timestamp format, and same thing and then I'm loading the file and returning the data frame. Okay, so for different formats, for different ingester. Okay, not rocket science. What I'm also doing is I'm adding a column called ingester. That's what you're seeing here to my data frame, which will tell me which ingester has been used if I want to debug if there's any issue. So here my column called ingester is Striker PXS saying I'm going to start calling anti-maskers COVID ingesters. Yeah, that's a very smart thing. I should modify my code for that. Thanks for that, makes my day. And you so the columns are either int 1, 2, 3, 4. Okay, nothing complex here. I'm just creating a default just in case there's something wrong or there's a new format coming down the way. And then I'm actually adding a column as well based on the file name, kind of reported date, based on the date in the file itself. Okay, so that's my main ingester. And what am I doing when I'm back to my loop going through each file here? And what am I doing is, if I'm the first cases, okay, in this instance of, well, not yet an instance, but this reference to a data frame here, you remember I just did that before, was null. But if it's null, I'm just going to assign that, okay? And if it's not null, then it's a bit like, adding the data. The way to do it with Spark is doing a union by name. So basically, I've got two data frames, and Spark is going to glue them together in a union way, like you would do in a SQL statement. Okay, so it's not, once more, nothing rocket science here, just standard data operating procedures, and I'm going to do that. I'm going to ask Spark to do a union by name. There's two ways to do it. You can do a union, or you can do a union by name. I choose a union by name because I'm not guaranteed that through all these things I'm doing through the ingesters, the columns are in the right order. So that's why union by name will look and will union based on the column names of the data frame. That's my ingestion. Okay. At the end of that, I've got pretty good, I've got my data in my system in a data frame. I've got a big data frame. And based on this big data frame, I've got all the files. And so if you're, if you know a little bit more about Spark or if you started reading the book, you know that inside Spark will create partitions. And in this situation, we will have one partition per file. Okay, and it has its importance a little bit after. So let's go back a little bit to the slides and move forward on our process.